Hello everyone, how is it going? So today we are developing an object detection system based on colors. So we can see these images up here, and Coca-Cola is of course a red color and the Pepsi has the blue color branding on it. So we're going to use those color profiles to do our object detection. So you can see some images coming up here and see how this system is working based on color profiles. So it's nicely able to detect these objects without any error. Now, normally something like this, if you're trying to do, you need machine learning and you need to do a lot of data training. So that takes a lot of computation power, it takes a lot of energy, and of course it's not real time. There is some latency in it, and the output that you get out is not very seamless. But something like this, where you're just using color profiles, it's very easy to develop. And this is nothing to throw machine learning or deep learning down, but it is to show how we can use basic image processing to do complex tasks. So it's a nice introductory application that we can use to enhance our computer vision skills. So we'll see how we can develop. And coming back to our folders, so I have this folder and I have this image up here, image.jpg file, and we'll see how we can detect the bottles, the color of Coca-Cola and Pepsi in this, and we'll see how we can do it. So I have this bottle.detect, and it's a simple Python application which is for now just reading the application for us and displaying it on the folder. So let's see what it does for now. So if we open command prompt, let me clear this, and if we just open command prompt, it will read the image for us. So this is how the image comes up, and it shows that it's reading. It's called it has the window name as image, and if I press the escape button, it goes away. So let's clear this back again and open our command prompt. So now the few things that we need to understand here is this image that comes up and reads, it's in the format of BGR, which is nothing but the RGB version. So it's R, G and B. So it has red, green and blue separate. So that makes it complicated because now you're dealing with a three-dimensional matrix. There's a matrix which holds all the red color values. There's a matrix for green. Similarly, there is a matrix of blue, which is very cumbersome if you're trying to manipulate or interested in that particular, in one color only. So in our case, now we are only interested in identifying where red color is available and where green or where blue color is available. So for us to pinpoint those two colors, it is difficult if we are playing with the three-dimensional matrix, because now you have to control three parameters at the same time. So it becomes very difficult. For that purpose, we convert a RGB image into something called as a HSV image, which is nothing but hue, saturation, variance. So let me show you what this is. So an RGB image has red, green, blue channels in it, right? HSV image has hue, saturation and variance, which is nothing but brightness. So hue holds all the color profiles. So you can see that it's having the red, yellow, green, blue, pink, red, every shade of color that you can imagine is already defined in the hue. Saturation is nothing but defining the intensity of the color, whether it is bright or dark or black. And brightness is, of course, brightness. And so these three channels are defining. So if we are interested in identifying the color of red, we just need to understand where the color of red is available in the hue channel. So you're not interested in what the other three channels are showing. So as long as we know where the red color is or where the blue color is, we are good with it. So that makes our job easier. So we'll convert this image, which is hosted in this frame variable, and we'll convert that into a HSV image. So let's see how we can do that. HSV equal to convert color frame. It takes few arguments. One is the frame and what kind of conversion you're trying to do. And we said we're converting a RGB or a BGR image to a HSV image. So that converts our BGR to HSV image. We're done with that. Let's display this thing and see how it comes out to be. And we save this. We come back to our command prompt and let's run this. So now you can see that the HSV image looks like this. The original RGB image or the BGR image is this, and the HSV image is this. So you can see the color difference, but that's not something we are interested in. We are only interested in converting into HSV so that we can utilize the power of HSV where we can control just one color profile. And we'll see how we can do that. So OpenCV has this function called as in range. So if you want to create a mask, and if we are interested in identifying only one particular color profile, we can use this function. And this is very widely used for thresholding as well. So if we say that there is a range between a range of colors between this and this, and just give me those colors that lie between these colors, range will do it for us. So it's called CV2 in range, and it takes 3 arguments. So one is the HSV image that we have, and it takes 2 other arguments, and these 2 arguments should be the color profiles. So whatever color profile you give between these 2, it will detect for us and come back. So we'll say the lower color profile is going to be for red, which is given by 0, 100 and 100, and the upper color profile is given by 10, 255, 255. So let's run this, and you might expect how am I getting these numbers? This is just by trial and error and understanding what these color profiles are. So this is nothing but an HSV image, and HSV, this is the hue value, the saturation value, and the variance value. So I'm saying the lowest value of hue is going to be 0, and the highest value of hue is going to be 10, and the saturation and variance are ranging anywhere from 100 to 255. So that's all I'm saying, and we will see how the mask looks like. So we'll display the mask. We'll call it mask here. We'll save this and we will run this. So let's see how this comes out. So we can see that it's creating a mask for us. So it has removed everything available. If we open the back original image, you can see that it has so much of content here. Everything is gone, and it's only displaying the region where the red color is presumably available. So you can see the Coca-Cola red color is there, and the portion of the hand is also available. So now you might ask, how do I know that it's only taking the red color? It is because this particular range that I gave here, it's nothing but the range of red color value. So if I open the HSV band here, you can see the red color is present here, right? So this is nothing but a value of about 10. It could be 10, 15, but roughly, even if you consider 10, that's good enough. So that is all what I'm saying here. So the value of HSV is ranging from 0 to 10. That's about it. So if you know that, you're good with it. You'll survive this. Now we have the information of mask. So once we have the mask information, we can display and we can draw the mask. We can draw the rectangles, and now we can do some computations. So this is the main crux of what we are developing. So now we can see how we can draw a mask function. So let's go ahead and first define the color profiles. And for that purpose, I have this function written here. and I'm going to copy that and paste it here. And I'll show you what I'm doing. So I have this function called color profiles, and it takes an argument integer of value, and the value could either be a 0 or it could be a 1. If it is 0, then it's going to be supplying the information for the Pepsi bottle, and it's going to say the name is going to be Pepsi, and the lower range is 95, the upper range is 115, and we're just returning those values. And if the value of n is 1, the name is going to be Coke or Coca-Cola, and it's going to have the lower value of 0, 100, 100, and upper value of 10, 255, 255. So where am I getting these numbers from? This 95 and 115, this is nothing but a range of 20 on the hue scale. And if you open the hue scale, this particular range, so here, somewhere here is where the blue color is available. So I'm saying that it's starting from 95 and going till about 115. So I'm just using that function. And coming back to the code, so I'm just saying that it's going to be 95 to 115. The value of saturation and variance is going to be changing from 100 to 255. That's all I'm defining, and I'm telling to return that information. So we can use this color profiles to get the function, get the value of the lower and upper, also name of the color that we are trying to detect. In our case, we have defined that the red color is nothing but Coca-Cola and the blue color is nothing but Pepsi. So coming back here, let's use that function in our code. So once we have those defined, once we define those functions, let's define some rectangles. So we have this HSV, and we'll say this, let's define there's a rectangle function, and we'll call it as a dictionary, and it's going to hold all the rectangles that our range function is going to define for us. So this range is going to give us all the mask, and all the rectangles or all the bounding boxes that we can identify in an image will be stored in this list of rectangles. So coming down to the mask, once we have the mask identified, we can use OpenCV's find contours function. So OpenCV has a find contour function, and it gives out two arguments. One is the hierarchy, and it uses the function called CV2 find contours. So this function right here, it's going to use the image, which is the mask image that we will supply them a little bit, and it will give out all the contours that it can see. So all the blobs in the image that we see, it's going to help us in identify them. So we are only interested in supplying the image, which is the mask and the copy of the mask. So we don't affect the main one. And we see that we are only interested in the external contours. So we say CV2 return external. And what kind of approximation or what kind of contour detection is going to use? That we define here, saying that it's chain approx none. And you don't need to know what this is. It's as long as you know that it's using find contours, it's going to detect all the contours, and it's just going to save it into the contours variable right here. Once we have this thing, we say that we are not interested in all the contours. We are only interested in the contour which is the biggest in size, and we do that by sorting all the contours in the descending order. So we say biggest contour is the sorted contours. So we use sorted function to sort all the contours and use only the biggest one. How we do that? By supplying sorted with all the contours, and we say that you're going to be sorting it based on the key, which is the area, and that area is given by contour area function. So OpenCV has this nice function which identifies the area of the contour, and it sorts them based on that area. Now it normally does it in ascending order, but we are interested in the most highest, the the biggest one. So for that purpose, we're going to be doing it in a descending order. So we'll say reverse equal to true, so that it sorts all of it in the descending order. So the biggest is the first one, and that is given by the array 0. So the 0th element of that sorted array will hold the biggest contour, and that is what we are going to take it and save and use it in the biggest contour function here. Now, what is the rectangle? What is the rectangle that this biggest is going to have? And what is that rectangle which can be drawn on that contour? This is used by, there is an OpenCV function which is called as bounding rectangle. So CV2 bounding rectangle. And what is this function? So if we give a contour, or if we give a blob in an image, this bounding rectangle is going to approximately draw a rectangle around it. So whatever blob you give, it will read that blob and say that this rectangle can enclose this blob. So that's the purpose of this bounding rectangle function. And we need to provide the contour, which is in this case the biggest contour. And the moment we give the biggest contour, it is going to give us the bounding rectangle behind it. And we just use that rect function. And this rect function, this rectangle, has information of the x coordinate or the y coordinate of where the rectangle is present. And it also has the width and the height of the rectangle. And this is available in the rectangle function. And we will use this rectangle function to display the name or display the bounding box for us. And how we do that? We do that by providing the WHXY variance. So we say, yes, let's draw the rectangle around it. So we use rectangle function of OpenCV. We say CV2 rectangle, and we use the original image frame, and we say the rectangle is going to be drawn on this x and y coordinate, and the thickness of the first coordinate is x and y, the second coordinate is x plus w, y plus h. And we're going to say the rectangle is going to have a color of 255, which is nothing but, I believe, the yellow color profile. So it's going to give us yellow color rectangle, and we're going to say the thickness of the rectangle is going to be 2, and we just close the function. So we save this. Let's go back and let's run this. Let's see how this comes up. So we have the mask image that we are not interested in, but this image, you can see that it's now drawn a rectangle, a yellow color rectangle around the red color box of the Coca-Cola bottle. So this is good for us. And let's also display the text. So if we come back here and we say not just draw the rectangle, but also do the text for us. So we say put text. Let me make this little down so that it's easy for us to see. We say frame, and we say Coke, and we say let's put the Coke on x and y, and you use the font CV2 font Hershey Simplex, and it should have a size of 1. Let's give it a color of 00255, which is red color, and you're also giving a thickness of 2. So that's about it. And let's save this. Let's go back. Before that, let me close this mask image. Now we are not interested in the mask, so let me comment this mask image. We might need it later on, but let's display this. and we can see that it is safely drawing the rectangle around the Coca-Cola bottle, and it's displaying the Coca-Cola Coke image as well. So which is very good and it's working for us. But now what about the Pepsi bottle? So the code that we have written, it's able to detect a nice red color bounding box around it. But what about the blue color? So for that purpose, we will need to have an if and else command. If and else, or maybe a while loop, or something that can help us in differentiating between both of them. So what we will do is, let's come back here and we say that once we read the image and once we also read the HSV images, I'm starting to think I might not need the rectangle function, but we'll come back to it. So we'll say for I in range of 2, and I'm giving the range of 2, which is nothing but 0 and 1, and we'll use that 0 to take the color profile of Pepsi, and we'll take the 1 for the color profile of Coke. So we'll call range I and 1 and 2. So, and we'll say name HSV lower, HSV upper equal to color profiles I. So what I am defining here is, in this particular section right here, I'm saying that if the I value is 0, give me the values of Pepsi. And if the I value is 2, or if the I value is 1, or the second, it's give me the color profile of Coke, which is defined here. And we will use that to use our mask. So let's bring this mask to our within the for loop, and let's remove the space here. So this mask is now part of the for loop, and instead of giving the color profiles manually here, we'll use the values that we defined up here. So HSV lower and HSV upper. So we have this here, we save this and we come back here. Now we can do the contours also part of the for loop, so that it can do it for both the Pepsi bottle as well as the color profile for the Coke bottle. And we bring everything we indent it so that it's part of the main for loop, and now it's all part of the main application, which is good. So everything is going to be drawn, everything is going to be come out properly. Instead of the Coke button here, so we are saying that it should write Coke, but now we are also playing with Pepsi, so we can't just have Coke. So instead of Coke, let's put name right here. So the name could either be Coca-Cola or it could be Pepsi. So let's see. So if we save this, if we come back and if we run this application, you can see that it's able to read both Coke and Pepsi. So let me go back to the code and explain if there's anything that is missing. So it's simple. You're just reading the color profiles and taking the HSV lower and HSV upper value, and you're converting it into a range, and you're saying that anything which is between the HSV lower and the HSV upper, create a threshold and create a mask around it. And from that mask, we're finding the contours. Those contours are pretty easy, but they're big and they could be of many different sizes. So we are interested in only the biggest contour, and for that purpose we use the sorted function. The sorted function sorts all the contours and it gives us the biggest contour by using it into the descending order. So once we have the biggest contour, we draw a rectangle around it by using the bounding rectangle function. By understanding where the rectangle is, it gives us the x, y, w, h value of the rectangle. And once we have that, we're pretty much done. We just draw the rectangle using the cv2 rectangle function, and we write the text cv put text. So that's about it, and it's pretty easy, pretty simple. And with a few lines of code, with about 30 lines of code, we are able to do a simple object detection using color profiles. We can see how a complex task can be brought down if we if you're using the simple basic image processing. So with that, we come to the conclusion of this video. If this is something which is helping you, and if you're trying to learn and grow in this field, do go ahead and subscribe to the channel. And we develop something where we are trying to develop our skills into the field of AI, machine learning, computer vision, and IoT. And if it's something that you want to join along and grow, do go ahead and subscribe to the channel. Until then, take care, stay safe, bye-bye.